Hello, my dear students. So our lesson for this session is all about modular arithmetic. Introduction to modular arithmetic. Many clocks have the familiar 12-hour design. We designate whether the time is before noon or afternoon by using the abbreviations AM and PM. A reference to 7 o'clock AM means 7 hours after 12 o'clock midnight. A reference to 7 o'clock PM means 7 hours after 12 o'clock noon. In both cases, once 12 is reached on the clock, we begin again with 1. Military time, also known as 24-hour clock, allows for precise timekeeping. It is widely used in the military, but also by emergency services, hospitals, and astronomers. For a military time, that's 1300s or 1300 or larger, simply subtract 1200s to get the standard time. So for example, if someone says, "Meet me in room 202 at 1545, you'd just subtract 1200s from 1545 to get 3:45 p.m. Those are actually just an example of what we call modular arithmetic. Okay, so we have here what we call modulo. So what is a modulo? Let's say, for example, we have 8 modulo 3. So we read this. We can read this as modulo. Mod is modulo. And what do you mean by that? Let's say 8 modulo 3. It means that you're going to just divide. Okay. So 8 divided by 3. So we have 2 here. Okay, times 3, that gives you 6, and the remainder is 2. Okay, so 2 is the remainder. And that is actually the answer for this. How about 8 modulo 4? So just the same, you need to divide 8 by 4, and you actually get a remainder of 0. So 0 is the remainder. And the answer for this 8 modulo 4 is 0. So I hope you get it already, that modulo means remainder. Okay, so if you have this, it is just asking you to get the modulo or the remainder if you divide this number by this modulus. So we call this modulus. So if you divide 8 by 6, the remainder is 2. So the answer is still here is 2. If the question is 10 modulo 2, okay, it is asking you to get the remainder when 10 is divided by 2. Therefore, the answer here is 0. How about here? 10 modulo 3. So if you divide 10 by 3, the remainder is 1. So the answer here is 1. Okay, so 10 modulo 4. Okay, so the remainder here is 2. And how about 21 modulo 6? So if you divide 21 by 6, okay, so there are actually at most there are 3, okay, 6 in 21, so that gives you 18, and then you subtract 21 by 18, you get 3. Okay, so therefore the remainder is 3. So modulo here means remainder, so you will just find the remainder. Let's proceed to modular arithmetic. Let's do some addition, subtraction, and multiplication of modulo. Let's say, for example, we evaluate 23 plus 38 modulo 12. So you just add these two numbers and you get 61, And then you divide the 61 by 12. We call this divisor, okay, modulus. So it's different from the word modulo. Modulo is the remainder, and then this 12 here is the modulus. So you divide 61 by 12 and you get a remainder of 1. Therefore, the answer is 1. Okay. How about this one? Subtraction. So just do the subtraction here. So you subtract 33 and 16, you get 17. Okay. And this should be, as you can see here, this should be modulo 6. Okay. So as you can see here, it's 6. So 70 divided by 6, we have 2 here, 12, and the remainder is 5. Therefore, the answer is 5. Okay, how about for multiplication? So you multiply 15 and 23 and you get 345, and then you divide that by 11 and the remainder is 4. Therefore, the answer is 4. So you can equate that equals 4. So the answer is 4. So that's how to add, subtract, and multiply modulo. Okay? So let's have some examples. So let's say, for example, 8 plus 2 modulo 3. So kindly try it in your assets there. Okay. So that's the sum is 10, and then if you divide by 3, divide it by 3, the remainder will be 1, isn't it? Okay, how about this? So if you add this, that gives you 12, and if you divide 12 by 4, the remainder is 0. And then you subtract 25, okay, by 8, you get 17. You divide that by 6, okay, so you have a remainder of 5. So the answer here is 5. How about here? 45 minus 30, that gives you 15 modulo 2. Okay, 14 is divisible by 2, so there's a remainder of 1. Okay, so we have here 30 modulo 4. Okay, so I think 28 is actually divisible by 4, so there is actually a remainder of 2. Okay, and then we have here 40 modulo 6. Okay, and we know that 36 divisible by 6, and then we have a remainder of 4, so the answer is 4. So that's how to get the modulo. It's just the remainder. Okay, so now we proceed to what we call additive inverse. So what is an additive inverse? We go to the simple arithmetic, not modular. In simple arithmetic, let's recall that if the sum of two numbers is 0, then the numbers are additive inverses of each other. For instance, 8 plus negative 8 equals 0. Therefore, we can say that 8 is an additive inverse of negative 8, or negative 8 is the additive inverse of 8. That is in the simple addition. But how about in the modular arithmetic? Okay, so the same concept applies in modular arithmetic. For example, if you add 3 plus 5, that gives you 0 modulo 8. Okay, so that's in modulo 8 arithmetic. Okay, if we use modulo 8, actually you can have any integer for that. Modulo 5, modulo 3, modulo 7, modulo 6. So in this example, modulo 8. So 3 is the additive inverse of 5, and 5 is the additive inverse of 3. Okay, so in modular arithmetic, we have to consider only those whole numbers is smaller than the modulus. Note that 3 plus 5 equals 8. That is the sum of a number and its additive inverse equals the modulus. Okay, so you can actually use that, okay, statement or concept in getting the additive inverse, okay, of a given number in modular arithmetic. Let's have some examples. Okay, so we have here different modulo n, modulo 5, modulo 6, and modulo 7. So in modulo 5, finding the additive inverses of 0, 1, 2, 3, 4 here, the additive inverse of its number is just the number you add. okay, to this given number so that the sum will be equal to the modulus, which is 5 here. Okay, so that when you get the modulo 5 over the sum of the two numbers, it gives you 0. So that's the meaning of additive inverse. Okay, so like for example, the additive inverse of 0 is 0 because 0 plus 0 is 0, modulo 5 equals 0. How about additive inverse of 1? It is 4 because 1 plus 4 equals 5. Modulo 5, it gives you 0. Isn't it? If you divide 5 by itself, okay, the remainder will be 0. Okay, so let's say for example, what's the additive inverse of 2? It's 3 because 2 plus 3 is 5. If you get the modulo of 5, it gives you 0. So just the same with the others. Okay, if you get the sum of these two, the given number and its additive inverse, it's equal to the modulus 5 here. So just the same with modulo 6. So as you can see, okay, the additive inverse of 0 is itself. For 1 in modulo 6, it's 5 because that's the number that makes a sum of 6. For 2, it's 4. The additive inverse of 3 is 3. The additive inverse of 4 is 2. And the additive inverse of 5 is 1. That's in additive, meaning in addition. Okay, so to find the additive inverse, we just need to get, okay, or to find a number added to the given number, and the sum will become or is equal to the modulus, given modulus here, like for example 6. So look at 7 here. The additive inverse of 3 is 4 because 3 plus 4 gives you 7. And if you get modulo 7, that gives you 0 because 7 divided by itself has a remainder of 0. So say, like for example, what's the additive inverse of 5? It's 2 because if you add 5 plus 2, that gives you 7 equal to the modulus. And to check whether the modulo 7 is equal to 0, 7 modulo 7 is equal to 0 actually. Because if you divide 7 by itself, it gives you a remainder of 0. So that's how to get the additive inverse. It says here, the sum of a number and its additive inverse should always be equal to the modulus. Okay, modulus means the number here like 5, 6, and 7. Let us proceed to multiplication or the multiplicative inverse. Okay, in simple multiplication, to find for the multiplicative inverse of a given number, their product should be equal to 1, as mentioned here. If the product of two numbers is 1, then the numbers are multiplicative inverses of each other. For instance, the inverse or the multiplicative inverse of 2 is 1/2 because if you multiply 2 and 1/2, it gives you 1. So the multiplicative inverse of 2 is 1/2, or you can say 1/2 is the multiplicative inverse of 2. This in arithmetic or in elementary, we actually term this as the reciprocal. Okay, so we reverse, okay, the numerator and the denominator. Like for example, the multiplicative inverse of 3 is 1/3. The multiplicative inverse of 1/5 is 5. Okay, so that is in simple multiplication. But how about in the modular arithmetic? The same concept applies to modular arithmetic. Okay, for example, in modulo 7 arithmetic, 5 is the multiplicative inverse of 3. Why? Because when you multiply 5 and 3, that gives you 15. And if you get the modulo 7 of 15, that gives you 1. Still remember that modulo means remainder. So 15 modulo 7 gives you 1. Okay? So here we will concern ourselves only with natural numbers less than the modulus to find the multiplicative inverse of a mod m. Solve the modular equation. Ax is congruent to 1 mod m for x. So you're going to find for x such that when you multiply it with the given a, the answer will be 1. Sorry for that. Okay, so let's have some example. This one is in modulo 7, but let's try some other modulo like in modulo 5, in modulo 6, in modulo 7, in modulo 8, in modulo 9. Okay, so in modulo 5, we disregard 0. Okay, so we start with 1 to 4. For modulo 6, we start with 1 to 5. For modulo 7, we have 1 to 6. So you subtract 1 from there. Okay, so you have for modulo 8, we have 1 to 7. Okay, 1 to 7, there should be 7 here. And then for modulo 9, 1 to 8. Okay, so how to find the multiplicative inverse? It's actually the number you multiply to the given number, and if you get the modulo of their product, it gives you 1. Okay, so let's say for example, what's the multiplicative inverse of 1 in modulo 5? It's 1 because 1 times 1 modulo 5 gives you 1. How about 2? What's the multiplicative inverse? It's 3. Why? Because 2 times 3 gives you 6. If you get the modulo 5 of that 6, it gives you 1. Remember, modulo is remainder. How about the multiplicative inverse of 3? It's 2 because 3 times 2 gives you 6. 6 modulo 5, the answer will be 1. So that's correct. How about 4? What's the inverse of 4? It's 4 itself. So because 4 times 4 gives you 16. If you get the modulo 5 of that 16, it gives you 1. So that's correct, isn't it? Now, how about for modulo 6? In modulo 6, so the inverse of 1, we're talking here of multiplicative inverse. The multiplicative inverse of 1 is 1 because 1 plus 1 times 1 is 1. Modulo 6 is still 1. How about 2? How about 3? How about 4? It's D and E. D and E here means does not exist. Okay? So why does not exist? Okay, so there is actually a relationship of these numbers with 6. What do you think so is the relationship with 2, 3, 4 with 6? Okay, so 6 and the numbers 2, 3, 4 has actually common factors. They have common factors other than 1. Okay, meaning they are not relatively prime, or yeah, you can say that they have common factors. Okay, so in that case there is no multiplicative inverse. Okay, 5, the multiplicative inverse of 5 in modulo 6 is 5 because 5 times 5 is 25. Modulo 6, okay, it will give you a remainder of 1 because 24 is divisible by 6 and the remainder will be 1, isn't it? Now, how for modulo 7, I hope you already get the idea or the concept here with the given 2 examples, but we have here 3 more examples so that you can generalize and you can actually recognize the pattern how to actually get the multiplicative inverse. How about the modulo 7? So for modulo 7, the multiplicative inverse of 1 is 1. The multiplicative inverse of 2 is 4. Why? Because if you multiply 2 times 4, it gives you 8, isn't it? And then if you divide that 8 with 7, there will be a remainder of 1. Okay? And how about 3? What's the inverse? It's 5. Why? Because if you multiply 3 times 5, that gives you 15. And if you divide 15 by 7, it gives you 1. Okay, so same with 4, the multiplicative inverse is 2, so just the same with that. For 5, the multiplicative inverse is 3. And then how about 6 in modulo 7? It's 6 itself. This, the itself. Why? Because 6 times 6 is 36. And if you divide that by 7, okay, and we know that 35 is divisible by 7, so there is a remainder of 1. Okay, so that's the meaning, and that's how to check whether it's actually the inverse. It should, if you get the modulo, the answer should be 1. Okay, how about 8? So same with example here for 6. 8 has are with numbers with no multiplicative inverses. Like for example, 2, 4, 6 has no multiplicative inverse. The any here means does not exist. Okay, does not exist. So the relationship of 2, 4, 6 with 8, they have common factors. Okay, they have common factors other than 1. Okay, so what's the inverse of 1? It's 1 because 1 times 1 is 1. The modulo 8, it gives you 1. How about 3? How about 3? It's 3. Why? Because 3 times 3 gives you 9. And if you divide by 8, there will be a remainder of 1. How about 5? It's still 5. Why 5? Because 5 times 5 is 25. And if you divide that by 8, there will be a remainder of 1. And how about 7? 7 itself, because 7 times 7 is 49. If you divide that by 8, there will be a remainder of 1. Okay, so I hope you already get what we call multiplicative inverse. And how about 9? So in modulo 9, 3 and 6 has no multiplicative inverses because we know 3 and 6, okay, have common factors with 9, isn't it? Aside from 1, except 1. Okay, so for 1, we have a multiplicative inverse of 1. Okay, so if you notice, for any modulo, you have 5, 6, 7, 8, 9. For number 1, okay, the multiplicative inverse is itself. Okay, and then for in modulo 9, the multiplicative inverse of 2 is 5. Why? Because if you multiply 2 and 5, that gives you 10. And then if you get the modulo 9 of 10, it gives you 1. So for 4, the inverse is 7 because that gives you 28. And isn't it 27 is divisible by 9? So there is a remainder of 1. So same with that, if we have the multiplicative inverse of 2 is 5, we can say that 5 is the multiplicative inverse of 2. Okay, also same with 7 and 4. And then for 8, the multiplicative inverse of 8 is itself 8. Why? 8 times 8 is 64. And we know that 63 is divisible by 9 and there is a remainder of 1. Isn't it? So that's how to find the multiplicative inverse, okay, of a given number in a given modulo n for any natural number. Okay, so that's all for this video. Okay, thank you for watching the video. So I hope to see you in the next video about the application of this concept, modular arithmetic. Okay, so bye bye for now.